Hello again. This is Math 2231 coming to you from the College of DuPage. The title of this lecture is called Midterm Solutions and Discussion. As always, please be attentive learners while watching this video. Problem number 1 asks you to evaluate the following limit or explain why the limit fails to exist. And it was the limit as x tends to pi over 4 of cosine squared of 3x plus sine squared of 2x. Well, this is a just plug it in. When you plug in pi over 4 here, you get the cosine squared of 3 pi over 4, which is minus 1/2 whole squared. And when you plug in pi over 4 here, you get sine squared of pi over 2, which is 1 squared. You add them together, and you get 3/2. Students should recall from the trigonometry that the cosine squared of theta plus the sine squared of theta is 1, but it has to be the same theta. Question number 2 said, evaluate the following limit or explain why the limit fails to exist. This was the limit as x tends to minus infinity of 4x over the square root of 3x squared minus 2. We did examples like this in class. But the way to proceed is to pull the 4 outside of the limit, and we're also going to factor the square root of x squared down here. Now the square root of x squared, of course, as discussed, is the absolute value of x. So this is x over the absolute value of x, and when x tends to minus infinity, this is going to be negative. So there is a negative in your answer. And down here, 3 minus 2 over the x squared is going to be just the square root of 3. So the answer was negative 4 over the square root of 3, or it could have been written differently. Number 3, I ask you to evaluate the following limit or explain why the limit fails to exist. This is the limit as x goes to 0 of 1 minus tangent of pi over 4 plus x over 7x. There were many ways you could have done this problem using trig identities. Some of you used L'Hopital's rule, even though we hadn't talked about it yet. But I certainly permitted you to do that. But this is the way I was expecting students to do it. So this is the limit as x goes to 0 of 1 minus tan pi over 4 plus x all over 7x. But you can factor out a minus 1 over 7. And that leaves us with the limit as x goes to 0 of the tangent of pi over 4 plus x minus 1. But 1 is the tangent of pi over 4 over x. So you see this limit is, in fact, the first derivative of the tangent evaluated at pi over 4. So this is minus 1 over 7 times the derivative with respect to x of the tangent of x evaluated at pi over 4. The tangent of x has a derivative of secant squared of x evaluated at pi over 4. And when you square square root of 2, you get 2. So the answer to this problem is minus 2 over 7. Question number 4, I ask you to evaluate the following limit or explain why the limit fails to exist. So this is the limit as x goes to 0 of sine of 3x plus 10x all over 4x. Well, you want to do this term by term, and we did problems like both of these in class. But you do it term by term, so this is the limit of the first one. Now here it would be nice if you had 3x over 3x, but you don't. But what you do is you realize you're very close to that because the denominator is 4 over 3 times 3x. So you can factor out 1 over 4 over 3, which is 3 over 4. And then you have sine of 3x over 3x. And as x goes to 0, 3x goes to 0, so you know this first one's going to be 1. So you have 3/4 times 1. Over here, you don't plug in 0, but when you're going to 0, you're going to have 5 over 2 because the common factor will cancel. So you have 3/4 plus 5 over 2, which is going to be 13 over 4. Number 5, I ask you to evaluate the following limit or explain why the limit fails to exist. And so what we do is we factor the numerator. We can pull the 3 out. And then we factor the numerator and denominator and observe that we will have 3 times this limit. And then when we factor numerator and denominator, and I'll notice here I'm factoring out another minus 1, making that minus 3. And so what we have is minus 3 times the limit of x tends to 2. I cancel out the common factor, and I can plug in 2. I get 6, so this is minus 3 times 6 is minus 18. This is question number 6. I ask you to evaluate, we're into the derivatives now, to evaluate the derivative of this at 2. Now, several people did this different ways, but the easiest way to do this is to use the fact that the exponential and logarithm are inverse functions of each other. So e to the 3 ln x is equal to x cubed. So the derivative with respect to x is just going to be 3x squared evaluated at x equal 2. 2 squared is 4, so that means this is 12. Okay, the next problem I had you to evaluate f prime of 1 for y equals f of x equal x to the 2/3 times x plus x raised to the 1/4 power. And so that's what we have. Realize this is x to the 1. And the easiest way to do this problem, you could have used the product rule and would have got the same answer, but the easiest way to do this problem is to probably distribute. So when we distribute this x to the 2/3 across this, we get x to the 5/3 plus x to the 11 over 12. So the derivative then is going to be term by term. This is going to be 5/3 x to the 2/3 plus this is going to be 11 over 12 times x to the minus 1 over 12. Plugging in 1 for x, we're adding 2 fractions, and we will get 31 over 12 as the exact answer. Question 8, I evaluated f prime of pi, or that's what I wanted you to do, for y equals f of x equal the sine of the tangent of 2x. Now this is a lot of chain rule, but when you take the derivative, it's going to be starting on the outside, the cosine of tangent of 2x times the derivative of the tangent of 2x, which is secant squared of 2x, and then times 2. So we have to plug in pi into all of these. The tangent of 2 pi is known to be 0, so the cosine of 0 is known to be 1. The secant is the reciprocal of the cosine, so if you square it, you also get 1 for that, and so it's 1 times 1, and then I have 2, and so the answer is going to be 2. Question number 9, I ask you to evaluate the derivative of f at 0 for y equals f of x equal, and it is a quotient, so your numerator is e to the x times cosine of x, and your denominator is 2 minus x. So the derivative is going to be the denominator times the derivative of the numerator. Now this numerator is in fact a product, so you have to do the product. So this is going to be the derivative of the first times the second, e to the x cosine x. And then it is plus, the first times the derivative of the second, but the derivative of the second is minus sine x. So this term becomes minus e to the x sine x. But then, so this is the denominator times derivative of the numerator minus, this is the numerator, times the derivative of the denominator, which is minus 1, all over the denominator whole squared. We plug in x equals 0, and we get 2. This is going to be 1 minus 0, so that is just 2. This is a minus 1, and so that's going to be plus 1, making that 3 over 4. Question number 10, you were to evaluate again f prime of pi, but this time f of x was 2 x cosine x times sine x. Now we discussed in class Leibniz rule for a derivative of a multiple product, and basically you're going to take the derivative of the first times the other 2, and the derivative of the middle one times the other 2, and then finally the derivative of the last one times the other 2. So if you take the derivative of 2x, you get 2, and then times cosine x sine x, minus, and then here we're taking the derivative of the middle term, which is derivative of cosine x. Now that's going to be minus 2x sine squared x. plus, and then last we're taking the derivative of the sine, which is the cosine, so that's going to be 2x cosine squared x. So this is what we get, and you didn't have to use the Leibniz rule. You could have done the product of the products, and that would have given you the same answer. But now we're plugging in pi. Well, the sine of pi is always going to be 0, so that makes these first two terms 0. And the cosine of pi is -1, but you're squaring it, making that into a 1. So this is 2 pi times 1 is 2 pi. Problem 11 was a related race problem. Joe was filling an ice cream cone. The cone is 12 centimeters tall and has a radius of 4 centimeters. If ice cream fills the cone evenly at a rate of 1.5 cubic centimeters per second, what is the rate of change of the height when the height is 5 centimeters? And I gave you a grace note showing you the geometry of this problem. So the volume of the cone is equal to 1/3 pi r squared h, and the picture looks like this. So we'll go into the solution now. So the volume is 1/3 pi r squared h, but we want to get this into a common variable. So as we did in class, we're going to use similar triangles. So h is to r as 12 is to 4, and that means I can solve for r in terms of h, and so r is equal to let's see, r is equal to 1/3 h. So where we have r, we're going to substitute 1/3 h. So we get the volume is 1/3 pi, 1/3 h whole squared, and then it's times another h. And when you simplify that, you're going to get 1/27 pi h cubed. And then we're going to take dv dt on both sides. So dv dt and the derivative with respect to t on the other side, this is going to be 1/27 pi. That's going to be 3h squared dh dt. And when we simplify that a little bit, or plug in the numbers, actually is what we do. 1.5 is really 3/2. And whenever we square the value of h, which was 5 centimeters, we get 25. And we have another factor of 3 there, so it's 25/9 pi dh dt. We solve for dh dt, and we get the exact answer is 27/50 pi. And the units should be in this centimeters per second. This is problem 12. It asks, for what values of capital A and capital B is 2x plus y equal b, tangent to the curve y equals ax squared, and that is when x is equal to 2. So let's go into the solution. So the tangent to y equal ax squared, that's going to have a slope of y prime, and it's going to be 2 capital A x. So when x is equal to 2, the slope of that is going to be, you put 2 in for x, and you get that is 4a. And so since we know that the line that we're looking at, and again here I've rearranged this a little bit, I solved for the y, but y is equal to minus 2x plus b. That means that 4a has to be minus 2, and so a has to be minus 1/2. Now, that also tells us that the curve that we're having, since a is minus 1/2, we have y is equal to minus 1/2 x squared. So when x is 2, if we plug minus 2 in for this, we get that when x is 2, y is minus 2. So the point that we have is 2 minus 2. And so we can use that to find out what b is. We just substitute into the line, and we find out that b is 2. So a is minus 1/2, and b is 2. This is problem 13. You were to find the equation of all tangent lines to the curve given by x squared plus y squared is equal to the whole of 2x squared plus 2y squared minus x whole squared when x is equal to 0. Now in the grace note, I did draw a picture, but I also asked another question, and that was, why are there only 2 tangent lines rather than 3? And the reason being that we have a cusp here. So from the grace notes, you should explain that there's no tangent at 0, 0 because it's a cusp. But anyway, you start with this, and you can figure out when x is equal to 0, we put x is equal to 0, and that will tell us that y squared is equal to 4y to the 4th power. And that means 4y to the 4th power minus y squared is equal to 0. You factor and you get 0 as a double root, but you also get that y is equal to plus or minus 1/2. So that gives us some points. In fact, we know that 0 1/2 is 1 point, and the other point is 0 minus 1/2. And those correspond to this point up here and this point down here. Okay, so you continue then. You have to take the implicit differentiation of this expression. And so that's going to be 2x plus 2y dy dx is equal to, this is 2 times the whole of 2x squared plus 2y squared minus 1 whole to the 1 times the derivative of what's inside, which is 4x plus 4y dy dx and minus 1. So we can plug in x equals 0, and we can also plug in various times x is equal to minus 1/2 or plus 1/2. When we plug in y is 1/2, we plug it in and we find out that dy dx is 1. When we plug in y equal minus 1/2 into the equation, we found that dy dx is equal to minus 1. And so what happens is our two equations are y equal 1/2 plus x and y equal minus 1/2 minus x. And so these are the two tangent lines. And then this was the third part of the answer. Question 14, this is actually a problem again that we did in class. We were to find the linear approximation to f of x is equal to 3x times e to the 2x minus 10 at the point x equal 5, and I ask you to put your final answer in the form y equals mx plus b. So what we can do is, if we put 5 in here, we get 15, and this is e to the 0. So the point x15 is on our curve. Then we take the derivative of this using the product rule. It's the derivative of the first times the second plus the first times the derivative of the second. And again, we have to use the chain rule. And then we plug in our point, and we get that f prime of 5. We're plugging in 5 now. We will get 3, and we will get 15. That's 1 times 2. That's going to be 33. And so we can do y minus the y coordinate equal x minus the x coordinate, and we get y is equal to 33x minus 150, just as we got in class. Finally, we have a word problem dealing with rectilinear motion. A particle moves according to the law of motion. S of t is equal to 2t cubed minus 9t squared plus 12t plus 1 for t greater than or equal to 0, and the units are feet and seconds. So we're to determine the velocity of the particle when its acceleration is 2 feet per second squared. Okay, well, we're going to look at the position function, which I've rewritten here, but when we take the first derivative, this is going to be the velocity. So velocity s prime of t is going to be 6t squared minus 18t plus 12, and that will factor into 6 times t minus 2 times t minus 1. And the acceleration, s double prime, is going to be 12t minus 18. Now, part A asks us if the acceleration is 2, what's the velocity? So we have to find the time. So we substitute 2 in for the acceleration. So 2 is equal to 12t minus 18. And we get that t is going to be 12 over, it is 20 over 12 is t. And if you reduce that, you get 5 over 3. We're dividing 4 into both terms, and we get 5 over 3. So now what we have to do, though, to answer part A is that we have to take the 5 over 3 and plug it into the velocity. So we put 5 over 3 in there, and we get that this answer to part A is minus 4 over 3 feet per second. Now, the second part says, part B says, when is the particle moving in a positive direction? Well, that's when the velocity is positive. So if we look at this, we can see that the velocity is positive between 0 and 1 and from 2 to infinity. You really shouldn't have gone from minus infinity because we told you t was bigger than 0. But the answer then in interval notation would be between 0 and 1 and from 2 to infinity, and I used the union notation here. Now we have one more question. What is the total distance traveled? Now I asked for total distance, not where did we end up. So it's not net distance, it's total distance during the first 8 seconds of its journey. And note, my dear students, that we started at 1 because when t equals 0, we're at 1. So during the interval when we're moving to the right from 0 to 1, you go from 1 up to 6, so that's 5 is the distance. Now during 1 to 2, we're going the other way, but we just go from 6 to 5, and so that distance traveled is 1. And then during 2 to 8, we went from where we were 5 all the way to 545, and so that was 540. If you add all these things together, you get 546. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. Strive to make a difference each day. God bless you all, and I'll look forward to seeing you in class.